Hey there, Internet. Well, as you can see, I got the milling machine torn apart again. Um, in my previous video, you may remember that I was wondering if this awful doohickey that I welded together real quick was going to work as the support for the Z. And I didn't clearly show this, but like the the gap here is only about 40 millimeters. And the reason that I actually did this in the first place is I could squeeze that in there and bolt it, and it was literally the only thing I could do. And the thing I think that really had my brain not able to come up with a better solution was this. And the way that this works is it sits down on top of that ball screw nut in there, and then the bolts run up into this bolt hole pattern. So I had to figure out how to not only have that inside of there, but this is actually wider than the gap in the column, and I couldn't fit the bolts. Just, you can see the bolt holes, they won't allow to bolt it and to have free movement. So after noodling a little bit, what I came up with was this. Now I did use this, and this actually worked well enough that I could make this part, and I'll try to focus it here. But if you look, I mean, there's some oil in there, but the surface finish on that that hole I bored in there is actually, again, if I can get it to focus, is really, really, really nice. Now I took my time. I used a 4mm 2-flute cutter, and I think it was going about, I want to say about 300 millimeters per minute. This is 1018 cold rolled, but the dimension came out really nice. It's a super snug fit, and yeah, this worked really well. The sides I just bandsawed and then cleaned up on the manual mill, and so this is what's going to actually sit on the nut, and I'll put it on and show you in just one second. So here it is installed on the ball nut, and it's a really nice fit. Now you can see how much movement is in here, because this is 200 millimeters long. Well, actually, it's 150 millimeters to this part of the ball nut. So even though it's a really tight fit, like, just to get it started is difficult. It's there's so much leverage on here. This is part of the reason that I had so much flex in the Z. So anyway, so this is the support, and then what I did here, is I just surfaced this, and I referenced these surfaces, which are parallel. So I just milled this down, and the surface finish actually feels really nice. And then I put in the 4-bolt hole pattern to match this. These are legacy bolt holes from another project. So anyway, that's how I'm going to attach the Z ball nut. And then on the other side of this, I had made a motor mount that bolted into these 4 holes, and there was really nothing about it that I liked. I had a nut in here and a bolt in here. I should have threaded this hole, but I didn't. And so every time I wanted to adjust it, I had to put a wrench on one side and an Allen key on the other side. And the motor was sitting kind of with the spindle up high, and there's a huge amount of leverage on it. So every time you'd want to tighten it, the whole thing would tilt. So I'm going to do away with this. I'm just going to put a 3-inch by 3-inch piece of aluminum square, 1/4-inch square, and then bolt that directly down to the top surface of this. And then I can just have a plate with the motor mount attached to that. So that's what I'll be showing next, but I got to make it first. Here's the result. The motor's not on, so I got about 1/10 of a millimeter if I really push on it. Before, I was getting about I was getting about 0.2 millimeter without much effort. So this is definitely an improvement. And I think if I actually hook the motor up and have the motor apply some holding torque, it'll be even better. So this definitely worked out really well. Okay, so I've got the spindle mocked up here, and this is designed to be direct driven, and there's quite a lot of wobble on this. If I fire it up, now if I hold this bearing up here, it's not too bad. But as soon as I let it go, it's quite noisy. So I don't know if I should try to support this or go with a direct drive. I'm not really sure, but my VFD keeps going into some deceleration error. I don't understand, but anyway, I can move this over and direct drive it. The problem is this is an ER11, and I have to turn this down if I want to do that. And if I turn it down, then I won't be able to get this bearing on, because the biggest collet I can put in here is 7 millimeter. So then I'll have to turn it down to 5 millimeter. And the bearings that I have that are 5 millimeter aren't great at high speeds. So I'm not really sure what to do. This is the smaller brother, and on this one I glued the shaft into the bearing with some Loctite, and this one runs much more smoothly. There's not really any wobble. Everything else is generally the same. The dimensions on this are different. The coupling is different, and the dimensions on the internal plus shaped piece are different. So I'm not really sure why this one runs so much smoother. This motor's substantially smaller. I want to use the larger motor with the VFD, so it's a bit of a dilemma. Okay, so here it is in a direct drive setup. This bearing, it's not a press fit, and there's definitely some vibration happening here, but I put a little resistance on the spindle nose. It doesn't really like that. This seems pretty stable. It should be spinning at over 10,000 RPM. You see that bearing has got most of the vibration in that bearing. I think if I Loctite that in, yeah, this might be workable. The bearing's getting quite hot. It's really high. I got it on a 1, 2, 3 block with the mount. It's kind of press fit into this. Yeah. It's probably good enough to put on the machine and take a test cut. I'm gonna figure out why this is. It just slows down and then doink. When I put that on, it'll be even more lovely. Although this one's not anywhere near as tall. Maybe I should put this back upside down again just to make it be able to compete with that ridiculous thing. Oh yeah, so will it cut? I got a piece of steel in the vise, so I guess we'll find out in a moment. So here it is. It's not trimmed or anything, but I'd say that's really darn good. Now that's just a 4mm roughing end mill, and this is the first cut that I've done. So I have to get the bearing seated in there permanently. It's chattering around because it's a bit of a loose fit. But I would say that this is going to work out really, really, really well. Very happy. Got the clamps going, and this moving to this square beam. I faced this off and squared it up. It was that construction grade stuff. It's kind of nasty, but it cleaned up pretty good. I'll do a more permanent mount. I have to redo this, obviously. I have to figure out a way to get it aligned, although it feels real good. And then I have to get the R8 spindle motor ready to rev. And I'm real happy. I mean, I'm real happy with this. Those chips were real small, but I don't really care. I mean, I don't need to show off with giant chips. That surface finish is great. And if I can get dimensional accuracy and that kind of surface finish in steel, that's exactly why I built this thing. So anyway, that's a quick update. Thanks for watching.